Hi! Memes isn't actually here right now. He's in the hyperbolic. He's in another castle.
So help me if he blew up the hyperbolic time chamber again.
I think he's pooping.
Although this is going to be weird.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one rule he had. I don't think it rules them all.
Yes, it's on the back of an infinite number of hyperrulal turtles.
Would somebody say cheesecake?
This brings up a very interesting question. Is cheesecake pie?
Fishies!
I love the fishes because it's so delicious. Franco fishing.
Fishies.
I could eat them every day, and my mom says that's okay.
I think I lost memes, guys. I'm sorry. I don't know where he is. I hope he's okay and brings back snacks.
There's people are commenting on the outrage of hacking the universe on a MacBook Air.
Here's some more stuff you can use, memes. Cut it all up.
I ate too much pie today.
Angry fish.
I think so. I think cheesecake is already pie. And it has crust, and so does cheesecake, which is why cheesecake is actually pie.
Hey guys, what's going on? How we all doing? Yes, Professor Wolf. I'm here next on the playlist. We don't need you buzzing in my ear. Now, hopefully Jen will be joining us momentarily. I said around a particular time-ish, and of course I was late and everything, so I sent her the link not all that long ago. But welcome everyone. I see you there, Kotov, as well as Whitechapel. Thank you all for joining us. But yeah, so we had done a little bit on the series a number of months ago and everything, and then I learned some more things. And I realized I was totally wrong. Now, when I say totally wrong, it was mostly on the scale, which we thought we were in that double cover layer of the hyperbolic figure 8 knot complement and everything. Meaning that we would have had to, basically our observable universe would have had to have been literally what it is. And coincidentally, from what I learned from Professor Keating is, in order to compass basically all the standard points on a ball or sphere or something, you have about 44,000 points. And if you take 10 to the 26 light years and you multiply by 44,000, you end up getting on the magnitude of about 10 to the 32 meters, which is very fascinating. It also has to be that's calculation for the nth sphere of maximal volume. That is the claim for the actual size of our realm of persistence. That would mean we would need to, basically, in order to really see curvature, we'd probably need to observe a couple times more than 93 billion light years. Which, it's like 13.8 or 14-ish billion light years. Yeah, but you're going on in all these different directions and everything. So, hey, welcome, awesome one. Yes. Pizza is a delectable thing. But I really hope Jen will be joining us. Well, that would be pretty sweet because I learned a lot from that gal. She's really freaking smart. And this was our own little series and everything that we're going to do. I also wanted to probe into a couple other things as well. But all right. So what we'll do is we'll bring up Jen's little painting here that she had done. Oh no, it was actually underage. Yes, yes. Because as I may or may not have attempted to upload a terribly last minute done article on Christmas Day. It wouldn't let me. I was going to upload to the archive and everything there. So I'm like, oh, I'm going to go with the mimetic of a Christmas thing. Oh, it's a Christmas miracle. It's not really a miracle. This is unearned information that I've had for a while now. And I just thought it'd be cool to kind of just put it out there into the academic ether. And then as I went to hit publish at like 11:59 on Christmas because I'm that terrible person, it's like, you're not authorized to enter in this category. Well, yeah, the other category. We are not. You actually need to be endorsed by somebody that's on there. As my heart slowly sunk, I realized this is probably a good thing because I rushed it far too much. I wanted to have true rigor and everything. Because I was just going to go for the little one-page thing. It's like, yeah, if you're going to do this, you should probably do this well. I tend to think I'm probably going to end up having Thad guide me through it sometime in February. Still need to book my flight. Vacation has been taken. That week I've taken off, so we'll do that then. But or at least in the meantime, we'll let somebody review my homework. But what we have here, this is Jen's painting of what she dubbed, and I think is actually the best model for just communicating things. Because initially when I interviewed Thad, I'm like, exploring hyperbolic reality. I thought it was a great thing, and just as my trolly nature, I'm like, that's a terrible idea. Because hyperbolic, it could mean literally the mathematical definition, or it's a hyperbolic statement. It's almost in jest, and in reality, you go into different definitions. It's like it could be taken as a joke, or it could be taken fully seriously. I feel like we need. That's why I like the HF8. It just kind of rolls off the tongue and it sounds cool, and I'm pretty sure we could have a little AI or actually human generated artwork that would go over very well. I mean, we already have E8, and people really seem to like that. And I tend to I wonder what happens if we took E8 and we slightly twisted it, kind of like they do with that bilayer graphene that ends up seeing superconducting properties. Because in my mind, it's like we hear about Cooper pairs. What the heck is a Cooper pair? It allows for superconductivity. I've watched some of these videos. I'm like, well, it helps you bump into the extra like energy state. I'm like, okay. I mean that's cool, but like, aren't we just most of the things we're modeling isn't like a waveform reduction or something? So we just kind of view it as this. So it's just gonna be like a blip, blip, and then blip, blip. In my mind, I was always like, what if electrons are like swing dancers? Those Cooper pairs, it's like swing your partner around and around, and they're just kind of like swing dancing. Because like, if you ever done swing dancing, it's like, all right, you get this balance, you're kind of swinging around and everything. But you do that, and it's like, all right, you're getting your angular momentum, you're picking up your velocity, if you would, and then you've got force. Also done that in mosh pits with people. You try to find another person around your size around. You kind of you join hands, you swing around. And if anyone kind of comes within your range, you're probably going to get knocked over unless they are quite massive and sturdy. That occasionally happens. But all I'm saying is, and then I had gone to the video. Oh, God, I need to find the actual equations because I plugged them into Wolfram Alpha and it literally showed. I'm like, all right, you get your vector field. It's like, all right, you can spin around here, you'd spin around here, you'd spin around here. But, oh, what we're talking about? Oh, step back, E8, blah, 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 blah. Oh, yes, the HF8 model. I really like the sound of that. And Jen's the first person I've heard that actually said it that way. But, all right, this is her rendition. The complement of the hyperbolic figure 8 knot. All right, so what do you have here? All right, looks kind of like, some may say, a fiber bundle. It really seems to happen a lot within physics tonight. Hey, Papa, what's going on? Well, we got the awesome one. Yes, yes. Oh my God, we're adding. All right, code up. The crazy thing about that, you're literally adding emojis and stuff. I believe in the Wolfram language now, you can literally add and subtract emojis, and it'll give you an answer, which seems completely crazy and ridiculous. Yeah, Team Wolfram literally made it a thing. It should make things very interesting. Yes, yes. Squirrel plus 8 equals pizza. I do have pizza somewhere, but I digress. So my initial formulation is, all right, you got this thing here. All right. So what I initially believed is, all right, the Big Bang, you get excreted out through here. We go through a whole space-time, yada, yada, yada. And eventually we loop back around. You go through here and all like the galaxies and supermassive black holes going to get crushed down and then spewed out as like a quark gluon plasma. So basically, you know, the Big Bang and it cycles and cycles. So I'm like, is that what Sir Roger Penrose is talking about with his conformal cyclic cosmology? Because that made a lot of sense to me. All right. So that was wrong. That was wrong, at least until the best models and conversations I've had. It's actually more spectacular than that. So, but now the thing is with infinity, people like, how do you deal with infinities? And this is one of the things where it's like, oh, you can't have infinity within physics. Okay. What type of infinity? We're talking about infinite energy. In my mind, at least the models that I tend to subscribe to and tend to be a believer in, there's going to be a finite amount of stuff and things. What is that? Oh, I don't know. Mass, energy. There's an equivalence there when you break it down. Basically, E equals M. Energy equals mass. Now, the particular flavors and the actual way it's actually set up, it may vary there. But at least the models I'm looking at, okay, so how do you actually do that? How could you actually have an infinity? Well, if you're dealing with an infinity related to time, at least as we conceptualize it, that's a freaking long time. So when we start delving into things like the multiverse or the many worlds interpretation and everything, it's like, well, you're gonna have a wave function collapse or something like that, which there's still gonna be some debate on. Well, if there's one wave function, I mean, wouldn't that have been built into the wave function itself? And it's like, really, us just taking a peek is gonna do that, but clashing together, just like a whole bunch of protons near the speed of light, that's not going to do it. I'm just like, I don't know. I don't know. I guess the jury is still out on that. I'm sure there's some really smart folks out there, maybe some folks even watching right now that have some ideas that may actually be correct. We'll see what happens. Heard a wise person once say that 2023 was the year to see. But so okay. So that initially I thought, all right, this was essentially our entire quote unquote universe. This in and of itself is okay. Let's say I'm gonna get up Wolfram Alpha here, but okay. Hypothetically, at least according to the calculations in 44, universe is about 10 to the 32 meters. Okay, it's the N hypersphere maximal volume. It's freaking huge. Like 10 to the 26. It's like 6 orders of magnitude. So the observable universe, yeah, add like 6 zeros. That is what I am conjecturing. Because I'm looking at the models. I don't think Thad's ever lied to me. So, I mean, he might be incorrect about some things. And that's one of the reasons why we're talking about it, to get this stuff out there into the digital ether. So some other folks will maybe share it around or maybe recommend it, be like, hey, this person's pretty crazy. But occasionally, crazy ideas may actually pan out. Because a lot of this stuff and a lot more folks, because what was it? Was it Maxwell or someone was like, I'm imagining like vortices and ether kind of working like clockwork. We're like, you're crazy. We're crazy. We love how you solve basically electromagnetism, but you're an absolute nut on this other stuff. Fast forward about 100-something years or so, and it's like, I'm hearing a lot of folks, including the good Professor Wolf himself, saying, yeah, we're imagining these things as like vortices and some particular medium. I mean, we're not going to call it the luminiferous ether, because a lot of folks said that that totally wasn't a thing. And we don't want to have to argue about the luminous ether. So we're going to use things like superfluid or whatever it is. All I know is in the space and arguments, perhaps we need a wee bit of counter space. Some may say an inverse to space as we know it. Some additional conjecture for some other times. But the funny thing is with pizza, you can actually describe circles and topology in a. I wish this was presented to me in something like this. It's like, all right, oh, what's a pizza's a 1. You cut it in half. You cut it in 4. All right, you get this. Now let's measure the angles of the crust and everything. And oh my God, I might actually try to do that. I'll probably try to teach myself geometry with pizza. Oh, it makes me hungry and interested. But yeah, there's some definitely well, that's the thing. That's why I use the term medium now. Not really sure what it is. It's superfluid. It's a luminous ether. Not sure. I think we're gonna learn enough. Hey, welcome, AJ. What's going on, my fine werewolf brother? But oh yeah, we had one of your cousins, Fizz, Celestial Wolf Girl. She did the little intro. The video is in the not in the doobly doo, but it's the beginning of this. But the interesting thing is this right here. Consider a black hole. Hypothetically, they say you got this thing called an event horizon. Once you get it, basically, once you get so close, once you cross that, you ain't never coming out. Why? Not even light can run away from it. So we have all these ideas. It's like, all right, well, if we get antiparticle production that just kind of happens within the vacuum where we say it's nothing, but there seems to be something there. There's at least energy propagating from it. Some calculations like it should be ridiculously high, but it's like 120 orders of magnitude different. Some say, well, the formulation of the question was a little bit different. That's totally fine. Again, we're only trying to describe the fabric of reality itself. Oh, imagine it might be a wee bit confusing. But the interesting thing is, all right, you cross that event horizon. And then, assuming you weren't spaghettified, basically, I think it's a smaller black hole, technically, you'll just be torn and literally into like spaghetti. Just because it tears you apart because of the gravitational force and everything. But let's say you had a really large, not angry black hole. It was just kind of chilling. Kind of like, I think, was it Sagittarius A star? I think that's kind of the black hole proposed in the center of our galaxy. It's not really actively eating. It's just kind of chilling out, taking a wee bit of a nap, if you would. Let's say you cross that event horizon. Some calculations say, nothing really changes. I mean, person will just see you just like slowly vanishing over time, but eventually you're going to collapse into it. This is what's claimed a infinitely small point of infinite density. It's like, honey, I mean, wouldn't you just invert or something? Like, even as a kid, I've watched enough Dragon Ball Z and stuff like that. Maybe it was from some of the Brawly films. It's like, you got this energy coming in, it comes in and it seems to almost invert or just then come out as like a green, like ball blast or something like that. It's like, what? I mean, would that happen? I mean, I'm still open to a bunch of interpretations, but at least according to mathematics and stuff, this is a double cover of the smallest balanced manifold, the Giesecke constant. It's non-compact, but the way it gets rid of the infinity is, oh, so rather than just completely collapsing into an infinitely small, infinitely dense point, and then making our minds wobble, to quote Kelly Bundy, what if it just took all that energy, some may say, I don't know, maybe a Planck force or something, and it just kind of looped around, did its little thing, and then went around again. And that happens forever. Forever is a very long time. And I think it's a decent way to deal with infinities. Why? Well, at that point, doesn't the many worlds interpretation, if we assume our own persistence is Turing complete, and I may or may not have noticed some similar things after Professor Wolfram when he was reviewing the NKS book on its, I think it's 20th anniversary now. May or may not have a copy coming tomorrow. But I'm like, okay, these see correlations with a Turing machine. Well, a Turing machine, well, if it's Turing complete, it can do any computation, but it might take an incredibly long time. But once you have a Turing complete system, it can do any computation. That's pretty freaking cool, because if it can do any computation, well, if the universe was Turing complete, that, I mean, doesn't that count for the many worlds? Because even if you had all this stuff happening, oh, the wave function collapses. I'm using this app that literally does a measurement that collapses the wave function and creates another branch. I'm like, well, if all the information on black hole can be encoded on a boundary, wherever that boundary is, I'm like, that's fascinating. I mean, if that collapse is captured at the boundary, and eventually, if you're dealing with infinity, which is something I got from Professor Sean Carroll, shout out Professor Sean Carroll, I'm like, well, if you're dealing with infinity, at some point, when you compute that branch as well, I'm like, do you account for the many worlds using something like this? That would be pretty cool. But awesome one. Hey, my mind rambles enough about this and that. Then again, I am a wee bit fluid. I'm just saying. But that's the thing. Well, being observed. Well, what if we're only existing, at least to our knowledge, within this particular space? There's a lot of things that I'm wanting. The interesting thing is, we'll have all this theory and stuff, and it'll be like, oh, hypothetically, we could do this or we could do that. And I'm like, that's really cool. But I sit back and I'm like, okay, that's cool. Then it becomes an engineering problem, like certain problems, like I think, what was it? The problem of turbulence was one of those things that, at least according to Professor Wolfman at one point, he's like, well, this is one of those things where a lot of physicists were playing around with, like, this is really hard. So they booted it off to like the material science people or anything. It's an engineering problem. Like, what? Wait, what? And it's like, all right, well, if you're an engineer and you want to get the job done, it's like, you have this problem. Well, are you applying this problem to anything really right now? If not, then why are you going to deal with the problem? Your job is to solve problems as an engineer. So I'm like, that's why the interesting thing when I hear about folks like Eric Dollard, whatever different folks may think of him, some of these concepts, it's like, I mean, again, if we were to take the man at his word, are absolutely fantastical. But when I start seeing some of the mathematical notation, I'm like, I'm hearing a lot of the same phrases and everything that I'm hearing right now, except the one thing that doesn't really seem to be explored is this thing called counter space. Because even if you're going to do like that circle and then breaking up into 7 circles and everything, it's like, isn't there still negative space in there? Is that counter space, or is that the imaginary realm? Because a lot of these equations will have I. It's an imaginary number. And I'm like, is it? Is it just something that's, like Kortov was saying, it's like, is it a wee bit unobservable? Nolan, you son of a gun. Thank you for joining us. I may or may not have some additional questions for some different things about just, I go back, I now see why some people have told me the things that they did. Because I jump in at a certain point, and then I heard words that were said to me. And then while doing research and looking for proper citations for first appearance of the hyperbolic vortex equation, I may or may not have added some different things to my Kindle library recently. And I go back, and I'm like, things are making more and more sense now. But I in hindsight, yeah. I mean, that's the thing. It's like, Where are these things coming from? And other folks have told me these things, and sometimes you move on. That's why I use the word a medium. Well, the crazy thing is, Whitechapel is a circle. If it has an articulation, that's an infinity. What happens if you have a circle within a circle, or a sphere within a sphere, which is essentially what we kind of purport as a Riemannian sphere, which is one of the big things. It's like, well, if we live in a universe and it has positive curvature, it'd be a sphere. Now, have we detected that positive curvature? Not really. Not really. Maybe a little bit, but we don't know. Maybe just freaking so huge we are yet on the scale that we can really detect it. Because usually they use the analogy where it's like, all right, if it's flat, it's basically a donut. Yeah, we're not good. We're just gonna keep on looping around and everything like that. And the Simpsons had an episode where Homer Simpson was conjecturing to what was it? Professor Stephen Hawking, God rest his soul. That okay, yeah, it seemed like a good idea. Why? Just because it's natural. Homer Simpson liked donuts, so that's a little bit of meme culture for you right there. But hey, what's going on, Snow? Oh, I see you there, man. I see you there. Welcome to going. Yes, we're talking about the hyper conjecture donut universe by Homer Simpson at the moment. See, I really should just make all these into just memes because they're already memes. I just use all the memes at my disposal. But oh god, yes, we're gonna eat our way out of this. If only we could. We got to be wary of those ghosts. Oh my god, are those ghosts imaginary? See, this is why I need Jen. Because I'm just getting off into a completely different tangent and just literally flowing from my mind here. But what were we talking about? Oh, okay. How to deal with infinities? Okay. So if you get a circle, oh, let's just we have the internet. Why wouldn't we use it? Okay. So we go to Ramani. Oh God, Google's ruined my spelling. Raman. Ian. Here. Boom. God, I didn't even. I'm gonna get another computer at some point. Okay. Go to the thing. Okay. What the heck is a Riemannian sphere? Okay. We're just gonna go. Google is pretty good for a lot of things. Okay. Just to show standard conjecture here. Okay. Yes, circle. Circle. Pretty cute. Or at least the best approximate. We won't get into the full platonic forms right here. We're going to assume our universe, our world and stuff is discretized. What's that mean? There's a minimum to something. That seems very interesting. It's a whole, if you ever heard of Zeno's paradox, what happens if you, I don't know, you take a piece of paper, you rip it in half. You rip it in half again. You keep on ripping it in half. And then at some point, maybe you get down to what? Maybe an atom? Can you continue to rip it in half? At least according to the Large Hadron Collider, we can tear them asunder into quarks, or what we believe are quarks and everything. Yet somehow, if you get a lone quark, another quark immediately pops out to balance it. That seems weird. Again, the horrible tangents. But see, that's interesting. I would love to see it take a picture of Earth. I think it's got to do that at some point, right? Although, oh, the glare from the sun. It's a Lagrange point. You could probably do it when it's a little out there. But see, I'm curious because at least according to the Dr. Becky video I saw, a headline pop up. We've now observed the furthest galaxy. It's like 13 point whatever or something like that. I'm just like, we assume we can only go back about 14 billion or 13.6 or so. We assume about 300,000 years after the Big Bang, and then things are going to start to become more homogeneous, and they're just going to kind of chill out a little bit there. But we're gonna have to see. But okay, what the heck is a Riemannian sphere? So all right, so we set it to like 1. You get -1. You get 0, you get infinity. Now, this is very interesting because, okay, on this plane, you get this red thing here, -1, 1. So whatever that 1 might be, what does that 1 represent? Whole 1, a unit. Some may call it a unit sphere. And then we got I, which is, all right, we're going in one direction, but we're also going in the other. Why do we have an I? Because it's technically a number. What's the square root of -1? Why? Because we're not supposed to be able to do that. But when we actually do it, it seems to work. And you got 0 over here, because that's like the South Pole. You got infinity over here. So again, that's just my base articulation just to show I, that imaginary thing, may actually be a legitimate thing. All right, we go to our friend Wikipedia. Again, take it for what it's worth. It's not a bad base point where some really smart folks, including good old Professor Moser, who was, oh God, what class did I have with him in college? It was something like strategies or something like that. It's supposed to be a really big thing. We're supposed to do the capstone project and everything and run a hypothetical business. And I kind of really wanted to do that at the time. One of the things he taught us is how to write a very short and concise memo. And he drilled that into our skulls. And I'm getting like an A minus AB. Because the last project, I didn't carry my own weight. So I had to knock myself down a few points. But all right. So we're going to go into a real quick little covering here. All right. In mathematics, the Riemann sphere, named after Bernard Riemann, is a model of the extended complex plane. The complex plane plus 1 point at infinity. This extended plane represents the extended complex numbers. That is, the complex numbers plus a value, infinity, for infinity. The Riemann model of the point infinity is near to very large numbers, just as the point 0 is near to very small numbers. Okay. Now, here's the point where I start to pop in some conjecture and everything. This is based upon some conversations with some really smart people. And again, some of these folks, they may not want to be actually mentioned at this time. Some folks are maybe waiting till, as I believe Captain Jack Sparrow said, the opportune moment. I can respect that. So I take a drink. But what does that mean? Okay, maybe there are literally limits on our realm of persistence. Let's say, all right, we could have it just because, I mean, when they tell you, it's like, oh, here's the interesting thing, and no knock on any folks that are religious or agnostic or atheist or anything, but I sit back and there'll be, and this is just an outside irony. Maybe it's me being a wee bit spectrumy or something, but I'm like, I'll hear some folks say it's like total atheist. I don't believe in God. That's like a fairy tale. And I'll sit back and I'm like, so, but you study science and stuff, so you believe that our universe came into being with some quantum fluctuations and then all of a sudden from nothing exploded out at an incredibly fast rate, just an infinitely dense, infinitely compact point burst forward, accelerate out, slow down, cool, then accelerate it again, and now it goes on forever in two directions and everything. And I'm like, I sit back and I'm like, okay, now if I was just a random thing with like maybe no, and again, I'm totally biased on this, so I'm just conjecturing here, but I'm like, if you tell me it's like something came from nothing or some all-powerful entity helped create our realm, I'm like, I think a lot of stuff in the old stories, I mean, we're gonna do Occam's razor. I mean, that seems to make a lot more sense to me. I'm not saying what is. I'm just saying about how sometimes maybe if we're exposed to something all the time, we just consider this all to be normal. We're like, oh, we take it for a given. Maybe we should question some things on occasion and do it with love and respect. Because I tend to believe you can say pretty much whatever you want. It's just what's the old meme? It's like, it's not what you say, it's how you say it. I feel like a lot of the internet, as much as I love the internet, it's kind of maximized for not always the best juju. Just my personal opinion. You do you, boo. But hey, Bone, good to see you in your kitty form. Like seeing him in Sully's comic things there. He's a good dude. But well, that's the thing. It's like I step back. I'm like, that would be incredibly hard. How could we get to literally the exact same point in our just what we know to be going on the best we can to get everything in literally in like this freaking Riemannian sphere, if we were to conjecture that, everything lined up at the same point to the point where it's like, I use that app that measured an electron, I get spin up in this other universe or other world, it's going to be spin down. I'm like, that's like impossible. But then I sit back and I'm like, again, according to Professor Sean Carroll, infinity is a long time. I'm like, if it was Turing complete and we do go through every single iteration, yeah. I mean, it could happen, I guess. It would probably take, I don't know how many billions, trillions, zettatillions of years or something like that, but Ferrum persistence was eternal. And all the information is encoded somewhere. I don't know. Is it kind of like just like a super save game spot? Oh no, we're going to the gamma function. That's useful for some other things there. But where do we do this? But well, here's the interesting thing, awesome one. Binary, apparently stuff within Russia, a lot of those folks, they were working with like trinary or something like that, computers and stuff. And apparently it had some success, but I think they ran into complications of binary, just this and that was easier there. But so, okay, let's say very, very large numbers. Okay. Hypothetically, all right. Size of universe. A Wolfram Alpha thing. All right. Diameter of the observable universe. About 93 billion light years. All right. In meters, that's 1.8 times 10 to the 26 meters. Excuse me, 8.8 times 10 to the 26 meters. But yeah, yes, Bone, we know you go between dog and cat. We respect you. I understand. It depends on the mood at the time. But Nolan, that's a beautiful thing. Because I sit back and I'm like, what was the let's do it guy? Let's do it. He's like, I'm gonna put this flag somewhere with a camera. And he ain't gonna find it. And people kept finding it on the internet. They kept finding it. Eventually, it's in like some like cabin in the middle of nowhere and everything. He's like, "Ha! You're not gonna find me now, internet." And the internet literally used it's like, oh, it's like we hear a plane going overhead. You're looking at like the flight data for all this different things. I'm like, okay, you're looking at that. At some point, they're narrowing it down to some dude literally drives by an area and is slowly beeping. And they're judging by the frequency of the beeping and everything. We're able to find it. That's that's people coming together for a goal, because I tend to think, just in my opinion, I'm probably totally wrong, but some of those folks were probably gamers. There's one thing that I learned by spending over a year of my life playing World of Warcraft. You present gamers with a challenge, or just the internet in general, don't doubt what they can do. And that don't just apply for Sonic the Hedgehog. But what else we got here? Oh, we got Lewis. Lewis, welcome. Yes, you found. Oh, I need to clip that thing from Majin Buu from Dokkan Battle. I found you. And then he assimilates people. But so he does, yes. over me and pizza. Oh God, we're gonna push pizza theory on people. No. We will offer pizza theory because that's the thing that I've learned. It's like everyone loves to buy. Nobody likes to be sold. That's the thing. If you go around telling people you must do this, you must do this, I sit back. It's like, aren't most people's reaction, especially on the internet, it's like, you ain't the boss of me. I mean, even when I have the boss of me telling me what to do, I'm like, if it don't make sense, it's like, yeah, that don't make sense. It's like if you come to people, but hey, listen, this is what we really need to do this and everything. This would really help. Could you help? It's like you ask people because if you ask people, you'd really be surprised at what some folks are willing to do. I've seen it happen again and again within these different circles of the internet. If somebody needs help, they've been a genuine person and stuff. You'd be surprised at just the charity that folks are willing to give. It gives me hope. Is that always the case in every situation? No. But then again, if we're gonna have everything just kind of happen again and again, there's gonna be every single possible outcome of everything. I always use the one where an 8-foot tall flaming gummy bear could crash through my ceiling right now, crush me, and I'm like, I use that, and I'll often satirically look up. And now the more and more I think about this, I'm like, God, in what iteration, if we follow the multi-world path, does that actually happen? Well, if you're going to go, that'd be one way to go. You're proving a point. It's not probable, but it's possible. But, well, apparently in neutron stars, we start to get nuclear pasta and stuff. That's another thing right there. Hold on, let me check my other thing. I don't want to share all these things publicly and stuff because I am lazy. Let me see if they boop Jen just in case. Well, Jen, this is why we get along because very often I told her I was taking a power nap. There's probably a good chance she took a power nap or was painting or something like that. Boop. There we go. All right, she's been booped. All right, and we are back to Wolfram Alpha. Okay. So, okay, the size of the observable universe, about 10, about 10 to the 26 meters. That's freaking enormous. Okay. So, we go to, coincidentally, I did a calculation that didn't even really make sense before. It came out to be about 15 quadrillion light years. But if we go by the outer bounce, the HF8 model, be the temperature. Basically, our realm is basically heat and electromagnetism. We got some mass in there, and apparently electromagnetism wraps around the mass boundary. It's pretty cool. All right. Oh, look. Square root of speed of light raised to the fifth times the Planck constant. Oh, that's over a gravitational constant. And the Boltzmann constant squared. Wait a second. 5.2? Where have we ever seen that before? I totally plan all this stuff out. Yes. Da-da-da. Where are we here? Oh, I know, I was totally wrong. It's supposed to be a value of 5.3. Oops. But it does have some other properties as well. I thought it may have been something. Okay, maybe this is for something else. Okay. Go back to Wolfram Alpha. Okay, so we get this, and this is going to seem like the kind of the laziest thing in the world. Kelvins? Use the magic of Wolfram Alpha. Yes, and my hand waviness. Change it to meters. With one S. Wouldn't want to be too fashy. But okay. 1.4168 times 10 to the 32 meters. It's about 50 quadrillion light years. That's pretty big. About 1.5 times 10 to the fifth size of that. Okay. Well, we just take it in meters. Because we can. And coherent settings is pretty nifty. I'm just saying. We throw our little brackets up there as we are preparing to do mathematical magics here because we can. And we have the power of Wolfram Alpha. Go! Whoa. And we get these units and everything. Squared. I looked into that before. That was pretty freaking sweet. All right, let's just take the meters out and just go with the straight numbers. Because we're delving down rabbit holes that pardon. That apparently if they work, okay, I'm stuck on that one time during one of the Wolfram live streams when it was, I believe Jonathan and Xerxes. They had some model up, and they're like, "Well, this seems to work really well, except there's one problem, Steven." It's like, "Well, what's that?" It's like, "Yes, when we have 0 divided by 0, it equals 0." And Professor Wolfram's like, "Well, that's crazy." He's like, "Well, we'll just set 1 point so we take that out." I'm like, "Is that when we remove like ignorable singularities? We're trying to correct it." It's like, what if we assume that was the right answer? Because apparently, within certain contexts, you can actually divide 0 by 0. I'm like, huh. I just find it interesting. Yes, the dedication of the lasagna. That's one of the great things. It's like physicists have a very long history of being some phenomenal trolls. Like Professor Richard Feynman. Oh God, the trolling he would do to Murray Gell-Mann, literally the guy that invented quarks and stuff. They shared an assistant between their offices. Oh, the hijinks and was it not intimidation, imitation. Yes, that word. Yes, we get lots of zeros. Sharing the now. Now Kotov? What if there's cheese in that crust? I had some pizza a few days ago, and there was cheese in the crust, and that made. Oh God, is that the actual save on the boundary? Are our literally words and our actions encoded in a delectable goo within the boundary of our realm of persistence? Oh, the memes. The memes. I feel like AI art, we could actually meme this into reality. I'm not saying that this is what's going on, but it sure would be sweet. Or more in this case, savory. Hey, Titan. What's going on, my man? We were just, I'm sidetracked on Wolfram Alpha. We were talking about what our realm of persistence or quote unquote universe may look like. And I was saying my initial conjecture was totally wrong. Totally wrong. I'm getting to the point here. So if we take that, all right. So if we take the model, the HF8 model, prediction for the size of the universe diameter, if you would, and then we compare that to the size of the observable universe, our result. This is actually something people can understand, which is the beautiful part. All right, the claim is what I'm going to conjecture is our actual universe. It's approximately 161,000 times larger than what we actually see right now. That's freaking huge. That's a very large number, but that's a conceptualizable number. And that's pretty cool. Why is it exactly 161,000? Like, I actually didn't think about that until right now. Huh. We won't worry about that. We're going to go back onto our pretty sphere. Okay. Yes, we're taking a look at the Riemannian sphere. It's a whole sphere within a sphere, but the extended complex numbers are useful in complex analysis. Oh yeah, we're talking about like the complex plane. That thing in math, it seemed hard, but I'm looking, I'm like, well, we're just using it's just a different representation. We're just like, if you're going geometry rather than just being like, it's like, all right, 0, 1, -1, infinity. Like, it's a circle. It's a circle. What happens when we're just doing like the other things? Because like you got a ball. Actually, you do this really well with a basketball. God, I think Professor Carroll should do more stuff because he's also a basketball fan. Go Celtics. But yeah, all right, you got I and negative I. We're just treating it as like a 1. It's just orthogonal to it, essentially. But orthogonal means basically, I think technically you could say like at a 90-degree-ish angle on the other side, on the flip side, if you would. But are useful in complex analysis because they allow for division by zero in some circumstances. I think we were just talking about that a wee bit. Well, that's pretty cool. But all right. But in a new way that makes expressions such as 1 divided by 0 equals infinity well behaved. For example, any rational function on a complex plane can be extended to a holomorphic function on the Riemannian sphere with a poles rational function mapping to infinity. More generally, any meromorphic function can be thought of as a holomorphic function whose codomain is a Riemannian sphere. In mathematics, a holomorphic function is a complex valued function of one or more complex variables that is complex, differentiable in a neighborhood of each plot in a domain in the complex coordinate plane. Oh, that's gamma by z. I'm just saying when we were going over some of, pi and back again. No. Was it prime and back again? Yes, I think that's. Did I add that to the toe playlist? If I haven't, I should do that because at one point it's like a prime number is a number only divisible by only one and itself. And Thad caught me when after I said that definition. He's like, "Well, why don't we include the one?" It's like, we don't. Why? Because I had watched, I think, a 3 blue plus 1 brown video literally about an hour or so before that interview. I was listening. He's like, "Yeah, one's not prime because we say it isn't." I'm like, "What?" And you go back, it's like we considered one prime because if you listen to the definition, which some people have amended, at one point it's like one was prime for a long time because it's like only divisible by one in itself. Well, one, that would mean one would be prime. It's like apparently if you take the one out, it makes doing certain calculations for like rings or different donuts and stuff like that easier. I'm like, wait, didn't we do like a lot of mathematics and like calculations and physics and stuff like that, like for like 1944 or 42 or something, like somewhere around there is when we officially made one no longer a prime. I'm like, I mean, is that a reason why some things aren't lining up? Because we did calculations under one set of axioms and then we changed the axioms? Hey, I'm just a dude on the internet that's talked to some really smart people. I'm just saying that I think there's a lot of fantastic stuff going on here. But yes, holomorphic functions. We're talking about that. I mean, I hear folks talk about a holographic universe. Is it, oh my God, that means we're like, I don't know, Jarvis from Tony Stark. I mean, does it mean that? Or does it just mean that's like, all right, we're an amalgamation being emanated from 2 points? Why? I saw the gamma function in there. The gamma function is pretty it's pretty freaky because it's like, all right, it has like 2 values. It's like, what is it, a 0.68 or 168 or something like that? And then it's also negative. What is a 0.168? It's like you just literally subtract 1 from it or something. And it's like, what are we subtracting the 1 from? What is the 1? The 1 can be pretty dang fancy. I'm just saying here. But hey, you may want to use the facility and or consult a doctor if your axiom is about to burst. I'm just saying, I ain't no doctor. Or yes, that one. Circle. Oh God. Oh no. You just gave me a topic for breaking the multiverse. Oh, the pizza universe. Liz will like that one. I did send her to math camp, so I gotta make up for it. We have to be fair. It's been quite the sport. A sphere. Oh my God. We could also maybe do the turducken conjecture. It's like a bird within a bird. Does that make a tastier bird? Oh God, the memes are endless. Oh, you go to like a state fair, it's like deep fried butter. Why would you ever do that? And then if you try it, I have never tried it, but apparently deep fried Twinkies. I'm not a dietitian. Be wary if you have nut allergies. But God, we've only got two. It's like we're having fun here. Just if we do the stream of consciousness, it's not necessarily the worst thing, or maybe it is. But all right, we'll finish up this little beginning part. So, in geometry, the Riemannian sphere is a prototypical example of a Riemann surface. Well, it's a Riemann surface. Oh, look at that! Huh, that looks like a Mobius strip. It's just kind of looping around. Okay, we're going to go into this real quick because I think it has a cool little animation. But in mathematics, particularly in complex analysis, a Riemann surface is a connected one-dimensional complex manifold. These surfaces were first studied and are named after Bernard Riemann. Riemann surfaces can be thought as a deformed version of the complex plane, locally near every point that they look like patches of the complex plane. But the global topology can be quite different. For example, they look like a sphere or a torus, or several sheets glued together. Huh. Where's the little animation? Pretty sure. So you're looking at this, it's like, okay. Huh. Because at one point it goes to helicoidal collapse, I believe. This is where no, on this. But essentially, that's where you got things kind of twisting. And if you got like the one really humongous circle and the one really tiny circle, eventually it's going to kind of like collapse and then go into something else. I think I'm butchering that, but that's okay. So we'll click off of that real quick. Is one of the simplest complex manifolds in projective geometry. A sphere can be thought of as the complex projective line, P1C. The projective space of all complex lines in C2. As with any compact Riemannian surface, the sphere may also be viewed as a projective algebraic curve, making it a fundamental example of algebraic geometry. Oh, look, it's looping around a loop-de-loop. Now, that's not necessarily a knot, but if you had another layering and we go by, what was it, the Rutherford? No, not the Rutherford. That's the atom. Rotemeister moves and stuff. You can determine if you can actually undo the knot, making it a fundamental example in algebraic geometry. It also finds use in other disciplines that depend on analysis of geometry, such as the Bloch sphere of quantum mechanics. Or branches of physics. And standard complex plane is also called the closed complex plane. Okay. Stereographic projection. Oh, look. That means at one point, oh, look, that's like a light cone. So at some point, you have the ability to connect everything to more or less everything, or at least in some particular limit. Okay. So what's the conjecture? What are we trying to say here? But dunking Twinkies in milk. Oh my God! You listen to Lady Arwen. But oh, Jax, what's going on, Jax Law? Welcome, my friend. But oh my God, there's so much activity and everything. This is pretty cool. But all I know is, okay, got all these different stuff and things. What was the point? Oh yeah. We go back to Wolfram Alpha here. Okay, so okay, we got the HF8 model of the size of the universe. We got the observable universe. Somehow it comes out to be about 161,000. It's a little weird, but all right, let's take that. Now, according to the analysis I've seen, this initial, we'll stop that for a second. This object here, let me bring this up, boom. Okay, let me share once again. Okay, go to Jennifer's painting. And okay, this right here, I initially thought that was basically like quote unquote universe or something like that. This would be like the 10 to the 32 meters, like the 15 quadrillion light years from side to side. Totally wrong. I was only off of orders of magnitude. About 40 orders of magnitude. essentially, this is what people might consider as a singularity. Because, okay, how do you get around the singularity? You literally get around it. Because the interesting thing is at this point, right here, I'll bring it up over here. Stop that for a second. And then we go back over here. So, see, there was a good reason why I totally brought up the figure 8 knot, even though I was disproving what I was trying to conjecture there. Okay. Where's, okay. 2. Link it 0, 0, 0, 0 of an isolated critical point of a real polynomial map of R4 to R2. So according to the theorem of John Milner, the Milner map of F is actually a fibration. Huh. And Bernard Perron found the first such F for this knot. Okay. Got some cool math. I need to learn how to use mathematics. I downloaded it. Or I'm at least paying for. Why? We should support the people we... Team Wolfram doesn't have a Patreon or anything, so I use their products, or at least I'm learning to use them. But, yes. Oh, snakes are very interesting. Now, I'm not saying that as a scaly behind me, that's an Ouroboros. But, cool. All right. So, we go back to the thing. So, how could you get around infinity? Or an infinitely dense, infinitely small point? Yeah, what if there's a limit there? If it's discretized, basically there's a limit, let's say, Planck boundaries. So it's like, all right, if you're limited by, like, I don't know, Planck length, Planck volume, or however you want to conjecture it there, it's like, okay, so let's say this is at about order of magnitude 10 to the negative 8. So basically you take the Planck mass magnitude, and just convert it to length. So, and again, Planck length is 10 to the negative 35. We're talking to 10 to the negative 8. That's a whole lot larger. That's like, what, like 27 orders of magnitude larger than the actual Planck length. But if that's essentially the point at density where you've got this complement happening, and this itself is going around a 0, 0, 0, 0 point within a Riemannian sphere per se, at this point it's like, well, don't we have a sphere? Might be 10 to the negative 8 meters. That's wicked frickin' small. And that is within a sphere of 10 to the 32 meters, or 15 quadrillion light years. I mean, from our perspective, isn't that going to appear as a point of, like, infinite density-ish? Something like that, an infinitely small, infinite density. And if you want to be technical, it's going around literally a critical 0 point. And at that point, you don't need to necessarily have all the mathematics blow up in your face being like, oh my god, it's impossible. Why? Because flowing through all, my friends, there is balance. It's literally balancing itself out as a double cover of the simplest, smallest, balanced manifold, the Geeske manifold, which there still seems to be like no real good illustrations of on the internet. I find that fascinating. Been doing a little research looking into that. Stay tuned. But okay, we've got this, and eventually within that too, you go down to 10 to the negative 18 meters, which corresponds to the Planck charge, just within units of length there as well, however you want to characterize it. And I'm like, all right, 10 to the negative 18. If you get a vortex throat or something there, at some point I'm like, all right, let's go to our friend Wolfram Alpha here. We'll quit out of that. And okay, so let's see, it's hypothetically diameter. Let's say a neutron. Shout out to Kali. Oh no, data not available. Let's use radius. We got some. Oh my god, data not available. Okay, we'll go to something simpler. Electron, like 10 to the negative 11 or 10 to the negative 15, something like that. 10 to the negative 15. Huh. That's pretty small. And actually, oh yeah, because we're in the negative, it's actually the smaller you get there. Okay. So if you were to have something like this, okay, that's pretty freaking small. Now, remember, this should technically be bigger than the nucleus of an atom because it's technically going around it. So if you got a proton stuff, it's going around it per se. At least often it is. The classical electron radius, yeah, 10 to the negative 15 meters. We get the classical use radius. Why does the electron have 2 radii? I don't know. If there's a double cover going on, might that explain some things? Why there's 2? Because you got one, you got another, and they're balancing out. And then we have like kind of no idea. Current experimental upper bounds is 10 to the negative 22 meters. That's even smaller. But that has the ability to fit into something that's 10 to the negative 18 meters. So, how about a quark? What do we think's going on quarks? My God, look at all those tasty quarks there. Oh, we've got magnetic charge there. Oh, we've got all our truth, our beauty quarks, and all that stuff and things. There are antiparticles, all those other stuff and things, which is essentially basically just a charge of the other side, or spin. Let's see, we got any data on for size? Oh, data not available. That's how unfortunate. But how about hydrogen? That's basically a proton with an electron. Let's do that. Okay, what we got for our information? Atomic mass. It's 1, but it's still got a little bit there. It's elemental properties. We go to more. Our blocks there. Our thermodynamic properties. Oh, it should be under material properties, I believe. Let's see. Density. Oh. It's got number 1 for density. How to no, it's the lowest for density. It's 118th. Oh, I mean, if we're gonna conceptualize it as a sphere, I guess. Atomic properties. More. Yes, yes. I'm totally abusing that. Thank you, Tim. Huh. Seems as if we're not quite sure. Okay, what's all this? Oh, God, I'm not even showing my screen. What a terrible human being I am. But, yeah, no, we're just looking at this stuff right here. Now, again, we'll go back to the last little thing, because that really wasn't even needed there. But let's go back to Jen's little model here. HF8. Okay. Boom. And we do the sharing thing. Okay. So, again, hypothetically, just conjecturing here, throwing it out here in the digital ether and take it for what you want. Now, if this is a really tiny small point in the center of our universe, and the universe is wicked freaking big, and this actually has a cycle, and this is going around like the Planck times, is going, think of a point of like wicked powerful energy, wicked super like almost near unimaginable density. Kind of sound like what we're kind of trying to describe as a quote unquote singularity. But in order to get around that singularity, we have a singular point, which Godzilla singular point, I think season 2 would be a lot better. But if we have that singular point, we get around it. We're literally just looping around that point and using that point as a balance point. It exists. It just exists a wee bit different than how a lot of people may have been conceptualizing it. Why? It's like, well, it's the power of the internet. Kind of taking people that have a drive and passion for things and give them a little bit of information. Maybe somebody noticed something that someone else did not. Maybe they brought it to their attention and that person kind of took the ball and they ran with it. And they did a whole bunch of different computations, calculations, and took the things that they learned over a number of years, started doing some great work. I know there are people out there that have done such things because I've been blessed enough to talk to some of these things. But oh no, dude, yes, changes a lot of things. Just if you can parameterize, I think it makes things make a lot more sense. But then again, you don't want to just you want to still be the forest from the trees per se, because yeah, you also don't want to just you got to treat folks as people rather than just you're just some standing wave function, some amalgamation of different stuff and things. But snacks! I apologize. I didn't see you and Gator come in. But yeah, like all the energies. Well, you could probably actually do a calculation there. I did some very naive things, but the thing that gets me is the potential dimensional fluctuations, because I kept on hearing Professor Wolfram say different things like that. I'm like, yeah, and then I look at some of the calculations and I'm like, it might be true. I think it's true. What does that even mean? Although the difference does seem to be 2. Because at one point it's like, all right, 2D surface plus 2D surface. We're going to assume some form of stereographic projection. It's okay, we take R2 plus R2. I can add it. Basically, we end up getting R4, or the hyperbolic space-time of general relativity. It reminds me of what Jonathan was saying about the ADS CFT model. You know, we'll do that because we're right here, right now. And he was nice enough to come on. So, okay. I'll just stop that. But basically, that central point right there, if we have the ability to literally... Oh, let's do that one more time. So, let's say you have this hyperdense region. If this is literally flowing, if you have the ability to actually go down the vortex, I was thinking on more of like a global scale, like an entire system scale. But if you got a wicked small point there, and you could start to really suck in pretty much anything, whether it's hydrogen, whether it's an electron, I don't know. What happens if it's an entire freaking galaxy, including a supermassive black hole? If it has the ability to literally suck all that stuff in, get it compressed and condensed, does that mean it could blast out the other end? Like, I don't know, maybe like a quark gluon-like plasma that we basically have said is basically a Big Bang. At that point, is this the Big Bang that never ends? Does it go on and on, my friends? Did some people start explaining it, not knowing what it was, and they'll continue conjecture? You're welcome. But I'm just saying that's the whole point with the eternal cyclic cosmology. Because if it does go on forever, infinity is a long time. So we'll close out that model, and then we'll end and just remark upon some of Jonathan's things that he had said before when he's going to explain that the ADS CFT basically, like, imagine things as a soup can. So I'll just go real quick. Boom, boom, boom. Go down to the notes, or the juicy notes, as Professor Wolfram might say. So here we go.
ADS, which is that is to say anti-de Sitter space, which is a kind of a geometrical gravity theory that can exist on the interior of a surface. That can be encoded in terms of what's called a CFT, a conformal field theory defined on the boundary of that surface. So you can have in the 1 + 1 dimensional case, which is the case where ADS CFT has kind of been studied most rigorously. You could imagine something that looks a bit like a soup can. So you've got like a sort of you've got a cylinder. So you've got a bulk gravity theory on the interior of the soup can, and you've got a sort of quantum field theory on the boundary of the soup can. And somehow, just by knowing the quantum field theory on the boundary, you can determine everything about the gravity theory on the interior. And so it's in cases like this where, as you correctly allude to, the notion of whether the universe is really three-dimensional or really two-dimensional becomes a little bit subtle, because you could say, well, the sort of gravitational part of the universe, the bulk part, is three-dimensional, but the sort of the quantum field theoretic bit that encodes that bulk theory could itself be two-dimensional. Everything going on in the three-dimensional universe could be encoded on a two-dimensional surface at the cosmic horizon.
If we have a proper label on the can, will we be able to tell the soup on the inside?
Yes, right, exactly. That's precisely the point, right? That everything there is to know about the soup, you can infer just by knowing the label on the exterior. Yeah.
Cool. All right. And as we do a little inception there,
Yeah, I'm
hi,
so
Jen.
sorry about that. I had a personal emergency come up, and then I haven't been able to get back to here until just now. But I'm here if you
Oh,
want to
no.
keep going for a
No
bit.
worries, no
and,
worries. No. I don't know.
My bad.
No. Hey, I miss so many different things and everything. I just like, maybe she took a nap like me and everything, because I've totally done stuff like that. No, you get a personal thing. No, I totally get that. No, don't worry about it. But the one thing is, how about this? I'm going to give you the floor. Is there anything you want to share real quick? Because I just need to take a quick bio break.
Absolutely, I can talk. Do you want to just screen share something for me before you go, or do you
Yeah. No,
run off
that's
right
that's what I'm insinuating. Yeah, no, if you want to share, I'll share your screen and stuff. You go into let
I'll
the folks
just
know a little bit
throw
stuff.
up because yeah, someone was like, "Oh, is there some way to like break this down to the particle in a box level?" And I'm like,
My mind has been entertaining some of those quote unquote
I want
ideas, and
to.
I'm just like, okay, I'm gonna. Okay,
Go
I
ahead
am.
and
I'm
be right
adding this.
back
All
though,
right,
and
I'll
we
be
can
right
talk
back.
when you come back. So we've got that shared, and I will just throw an image here. All right, so someone was like, "Is there some way to break this down to the particle in a box?" And I'm like, "Well, in a way, the particle in a box is actually more complicated than what I'm presenting, because you're gonna think about like, okay, what does it actually take to get to a particle in a box? Probably think like not that much, and this is way more complicated than that, but it's actually not. This is informationally way simpler if you want to define information as like something based on starting with axioms and then going forward with whatever those axioms allow. So to get to a particle in a box, you need to have a concept of numbers, and you need to have a concept of modeling that particle in a box. So you need mathematics, possibly multiple levels of mathematics, because you have to talk about a box, that's mathematical object, and then you're putting something in that box, which is a graph to represent the probability of observing a observable. Okay, so there's a lot of structure there. You're assuming that this thing is a function of time. Well, how can it not be a function of time? It's like, what if time is the effect and not the cause? Like, how would you know? So my point is that it's like the particle in a box sounds really simple, but it's actually not. And that's where you kind of have to realize where's the complexity actually coming in that makes the particle in a box actually, in a lot of ways, going to be something that holds you back from understanding this kind of stuff. So you got the Cartesian plane, and that has information in it, which is that parallel lines have certain properties, and by association, perpendicular lines have certain properties. And then you get trigonometry out of that, because trigonometry derives from a relation between something derived from perpendicular lines, which is a right triangle. So even if your Cartesian plane didn't have all the problems with the reals, and you were just like, well, it's just the rationals, I'm just going to throw the rationals on there and it doesn't matter because my rationals are close enough that, like, if I'm truncating computationally, it doesn't matter, I just use rationals. You still have that same metaphysical structure that your problem's inheriting. Whereas this isn't inheriting the same metaphysical structure. Like this structure here, these structures we're looking at in the screen right now, they're not happening in 3 space. They're not inside of a Cartesian plane. Okay, so Now, I know we've talked before, Katov. No need to get upset. It's like, if I say by our definition, I'm going to cause confusion because if we're talking about Western physics, it's not our definition. It's my understanding of it because I use a system that is consistent with certain aspects of modern physics, aka least action, but by association, that does knock out other stuff if it doesn't abide by least action, right? So you can argue, or I can argue, that Cartesian plane doesn't really abide anything close to what you might call, metaphysical parsimony. So
Continue, Jennifer.
all I'm trying to say is it's not like about right and wrong.
From what he's a balance of, all right, I'd be trolling and I'd be thrown up to the point where it's like, I tend to think he's a crazy person like myself.
Oh no, he's not. He's really smart.
Oh no,
He's
no,
really
he really
smart.
no. That's why I had him on.
Yeah, like he's just like not on. He's not seeing things my way because like it's a completely, pretty much different way to look at physics. So it's totally fine.
He has his own models that surprisingly seem to keep popping up occasionally and gets my old noggin drunk. But okay. Seeing these lines, you're explaining the lines.
Okay, so think about mathematics is to language what language is to.
Gotcha.
Did that make sense?
Yes.
So does language actually bring meaning to life? No, but it sure as hell seems like it does. Does math bring meaning to language? No, but it sure as hell seems like it does.
I like where you're going. Continue.
So all I was saying is that, like, I want to give this example of someone who had asked about, like, can you break this down to be simpler? Because he's saying, like, this is too complicated. I'm trying to say, like, in a way, I totally get why it seems more complicated. There's a lot of, like, there's 59 balls, right? I get it. But there's no Cartesian plane here. This exists in advance of what you might call a Cartesian plane. But there isn't actually a Cartesian plane. My system doesn't have a Cartesian plane. I mean, we consider that a piece of paper that, we don't need to make pieces of paper in the formulas. We already have paper. We don't need more.
Oh no, are we ushering in the flat universe paradigm?
Well, it depends what you mean by flat.
That's a perfect response. Thank you, Jen.
Well, there's the thing is there's two definitions of flat, right? One is literally like a piece of paper, and the other one is having no thickness. So the one where will these field equations satisfy something with zero thickness? Yeah, there'll be minimal perturbations of zero thickness surfaces, which is what these are. So we've got all these surfaces. Like, I know that it seems like the surface is actually not zero thickness. Okay. I get that. I didn't make this, first of all, / like, I'm not saying you're saying that means or anything. I just want to make clear to people, like, it's zero thickness. They add a little extra thickness so it looks like metal so that it actually, it's easier to see, basically, whereas a computer can't do zero thickness either. And why can't a computer do zero thickness beams?
Because it's discretized.
Very good. And why is it discretized?
Because it has I like that question. Well, one, we have limits for our computing, and the crazy thing is those limits for computing may actually, I'm not saying they directly correspond, but there may be limits to reality.
No, I was just saying because of bits and bytes.
Oh, that too.
Like, everything on a image on a computer is at least 1 pixel thick.
I need your help for a computation. We'll talk again another time about that, because I was working on computing exactly like what one actual byte is. No, bit, because it's 8 bits in a byte, right? I think that's how it goes. I always get confused
I think
about
so,
that.
yeah.
Yeah.
Well, isn't it 2 to the power of something?
I mean, that sounds like it's somewhere in there. I was working within some thermodynamic equations. I'm like, I need to talk to Jen, because I'd gone to certain places, and all of a sudden it's like one particular equation popped out. It had a lot of E, a lot of pi's. I think it had like a 5 and a 7 or something like that. And I'm looking at it, I'm like, everything else, and like it popped out at like 16 or like 19 digits. And I'm like, everything else was something crazy in Wolfram Alpha, but that one persisted. What the heck is going on here? And so I'm looking at that and I'm just like, okay, I need to delve further in there. And then again, ADD and stuff. So
We'll get
I,
there
I
eventually. It's just like a matter of understanding how the diagram that I put there is like the reason why atoms aren't really a thing. Like discretization and atoms aren't the same. It's kind of like, a fabric having a pattern. It's like saying every single part of the pattern's the same or no different or the same. And we're just saying, well, they're the same. So discretization being the 59 and non-discretization being the fads thing. So basically, I'm just saying, like, it's the same information. One's just basically the dual version of the other.
I mean, those are probably better words than what I was saying. I'm just looking because when I saw that, I'm like, it's the QMPT. Oh, very fascinating. I mean, I want to say it surprises me, but I'm just like, I'm pretty sure we were going to find some other derivation of that at some point or another. So I mean, I just thought it was awesome.
Well, it's basically the manner in which matter is numerical.
Our conceptualization of it, or how we
are learning the manner in which matter is numerical through concepts. Yeah. Like the concepts are the things that we access. And then there's this deeper truth that there is a numerical side to matter. And it always comes down to 3 + 1, but it can, be also 118. It's not a contradiction. It's just that it's a structure built out of 3 + 1. So in the same sense, like if you can model whatever correctly enough and get it dead on that it lines up with like the signal nature of reality, then you could theoretically derive some of these things. Or all of them, I guess.
That was, that was another. Well, it's a different. I mean, it sounds like it's to use a Professor Wolfram saying it's computationally equivalent. You could just say it's combinatorically equivalent because depending on how you're kind of slicing it, how you're setting everything up. I mean,
well, combinatorics is part of combinatorics is a type of computation. So we're probably talking about a computation that hasn't been defined yet. Some new combination of things. That's probably going to be obviously related. It's probably going to be a combination of like things we already know perfectly, like the permutations and combinations kind of stuff. Like in the periodic table, obviously order matters. You know how there's that bifurcation between permutations and combinations. One of them order matters, the other one doesn't.
I'm sorry, Professor Carroll just distracted me because I was going back to something I'd listened to right before I did the stream, which it kind of went into what it basically was. It sounded like you were saying the same thing you were just saying. Say that one more time if you could, please. Hey, Sherry. Thanks for popping in. Good to see you.
What did I say?
Combinatorics is a different. Okay, now I remember. I think that's
order
why,
mattering. Order mattering versus not mattering.
Okay. Does that explain matter?
Order matters in combinatorics and not in permutations, I think. I forget, but are you aware of this distinction?
I think that's why Professor Wolfram just at one point he's like, I'm just gonna throw it on the gauntlet. I'm just gonna do the Roolean. Why? We're just gonna encompass all of the things, all of the computation and everything. And it's like, power to you, man. Power to you. You're trying to figure out all the rules and everything. I'm like, well, if you're gonna say we're gonna encompass all the rules, well, you're gonna eventually get like things as we know it. I mean, it's a very broad swath, and I mean, hey, I mean, I think
that means rules are a thing, and they aren't.
Okay.
Not in any real way, anyway. Obviously, there's the laws of physics that are unbreakable, but rules aren't laws, so there's always nothing. I don't know. Rules kind of seems like something computers does, not reality. But we'd have to come up with something different because it's not a combination or a permutation. It's something else. It's something more than a combination. It's where order matters and dimensionality matters. So
So
something
basically,
like that. Go ahead.
so basically, are we saying, what is it? Associativity. Associativity is multiplication, but there's a certain thing where I think once you either get quaternions or the octonians, I think the octonians is ones where specifically the order matters. Because normally the associative, it's like, yeah, as long as it's multiplication, as long as they're lined up there, doesn't really matter which one you have first, like 5 times 9 or whatever would be x times y. But as soon as you get to an octonian level, if you switch it to y times x, the associativity is gone. So, like you were saying, the order actually really matters then.
Not always. No.
Okay.
Sometimes it does. Sometimes it
Well,
doesn't.
it would depend upon the dimensionality, which I think it wasn't that what you were kind of
Think
just
about it
saying.
like if you're in the first dimension, is there any chance you're going to reach the dimensional limit? Not
I
really,
don't know.
because the dimensional limit is 3 plus 1. So if you're only in the first dimension, you only have one way to reach the dimensional limit. And you see what I'm saying? Like, there's
I noticed you changed your handle,
a limit.
Jen. I'm just gonna say, I'm like, wow.
Because what do you mean, my YouTube thing?
Oh yeah.
Is that what you're talking about?
Oh yeah, that is what I'm talking about because
My original one wasn't even my handle. That was chosen as a joke like 15 years ago when I had no clue what it was and I had no way of changing it. And finally I was like, okay, thank God.
Oh, okay. I mean, I still kind of like it because I'm like, well, I'm not going to assume that. And the more and more I think about things, I'm like, that's why when I make some of those arguments, I'm like, Psych is a Messiah. I'm just like, go over here right now. Let's operate within this because it would explain a lot. But
I guess
go
there's
on.
only one limit in the sense that quantum state exclusion is one rule. If that makes sense. Yeah. So
the Pauli exclusion.
yeah, like that's one truth, not two. So the question is, how do you get numbers from what amounts to negation?
Ooh.
Because
Huh.
think about it, is the Pauli exclusion principle essentially a negative axiom? Oh,
Huh. Thou cannot occupy the same quantum state. Huh. That. Oh my God. Why do I think the gamma function's going to make a reemergence? I talked about it for like 30 seconds earlier in the stream, but
I mean, I think Ramanujan felt the same way, so it's not unprecedented. Like personally, I don't see it as much. Like I think stuff like art and beauty kind of gets closer than math, but I do see how there's some symmetry and beauty in math for sure.
well, I mean, art is beauty. I mean, that's kind of geometry, right?
It's connected for sure. The connection between art and math is like aesthetic has an element of symmetry to it.
Well, I mean, that was Noether's theorem from was it Professor Dr. Emmy Noether? Like she was one of the ones back in the day. She was like an OG. It's like, yeah, there's gonna be some form of a symmetry with all this. And while she was studying cosmology, and people still use Noether's theorem. I think Professor Einstein, he literally cited her. It's like this is very important. This is a very astute thing. I think I need to do a segment like "Badass Women of Science" or something.
So what is
like
Professor Carroll saying here?
Oh, let's play this beautiful beam footage.
But the potential is changing. Okay, the second derivative of the potential. So there's a very mathematically precise way of saying your wave packet is localized enough to pretend that it has one single location. And then you can show that minus dv dx expectation value turns into minus dv at x bar dx. And then you get the classical limit back. So that's then just the force on the particle, okay? So what it's saying here is that Ehrenfest's theorem gives you classical motion for a quantum wave function in certain circumstances. certain kinds of quantum wave functions can behave classically and some can't. Okay, this kind of wave function has a chance of behaving classically. This is in the classical limit. This kind of wave function up here just doesn't behave classically at all. So you have to be a little bit careful about it. So everyone understands that. Sometimes they gloss over. There's a question: why is the wave function ever localized? So you have to answer that, but those can be answered.
Cool. I guess we got work to do.
Yeah, well, we have to make a distinction between localization and collapse. And if it's just like, what is that musical instrument where pumping in and out? Damn, I forgot
Trombone.
what it's called.
The horn.
In the other direction, like it's like you're clapping.
A cymbal.
I want to say harmonica, but it's not a harmonica because that's the one you blow on. But anyway,
Yeah.
Anyway. Okay, a rarefaction, like sound waves.
Okay.
If a collapse isn't really a collapse, it's just a narrowing, then that kind of solves the problem, doesn't it?
Are you saying that we don't need to have infinite branches of a wave function? Potentially?
Well, the universe.
We don't need to.
Go on. If you want to look at it as a mathematical object, it's a surface that has a conservation of some type of tension.
Mm-hmm.
And within that, it's basically like everything's happening on the surface of the hyperbolic complement thing. What are we going to call that, by the way? Has that taken to calling it any short form or anything?
I'm just saying HF8. I like that. No, that's beautiful. Because number one, we get some real cool AI or human drawn art for it. It's so simple. It's so descriptive and EHRE thing, so people's minds are on there. That's what literally when I wrote, I totally may or may not have done a very poorly written paper that I'm glad it wouldn't let me upload to archive. I was going for the whole Christmas quote unquote miracle meme. I'm just gonna put this out there. I've been saying I'm gonna do this. I'm saying I'm gonna write this. I wrote a very short thing, and within that I mentioned HF8. Just because it makes sense. It's encompassing because it's like that's books. He is a philosopher of physics. I will totally say that. And I'm not going to do the hyperbolic reality. That was too trolly. HF8, it's the HF8 model as far as I know it. That's pretty much what I've been referring to it as.
Pause. What's hyperbolic reality? What's the rundown on that?
Oh, that was my first stream with Thad.
Okay.
Kind of trolling.
And what was the context of hyperbolic reality? Was that what he was suggesting to call it, or
No. That's why I told him not to call it. Whatever he does, do not call it hyperbolic reality, because one, it seemed to be an accurate description of the model. But two, if you take the alternate definitions of both those words, it's literally the ultimate troll. So I'm like, don't do it. Don't do it. No, an HF8 sounds
ultimate troll, eh? Well, hyperbolic reality, I don't know. I'm gonna have to think about it. Have you showed any of the art that you did? I feel so bad for being late, by the way.
Just, no. Hold on, I got this.
If I miss any, I've got some too. Nothing of the QMPT. I tried to get Midjourney to make QMPT, but I can't describe it accurately enough that it actually gives me anything other than like something that looks like a pile of marbles. So that's on pause.
Yeah. So what?
I haven't even tried the HF8 yet. I haven't even gone there. I've been in like fairy tale land. I've been like, okay, let's do this right now. Everything I've ever had in my imagination, I want to see it right now.
No, you learn from the internet, and the internet learns from you. God, it's like Mother Russia. But so I just put in like twin vortex figure 8, and this is what I kind of got out, and I'm just like, it's a beautiful thing. I don't think it's exactly accurate at all there, but I'm like,
honestly, it is amazing that you're using it for that purpose, because I think this is a way to really enhance creativity, which I see as a virtue. Just so that's I don't think I think creativity is an unstable virtue, which can be good and not so good. It's just I think it's good to make the best of stuff. Technology can be used virtuously or not, and I think using it to flex your imagination is great.
Oh no, I like it
You
because
find it gives you more ideas to look at the images.
right. Well, it's kind of like Wolfram Alpha. It's like I was just kind of scared at math. I knew I could do math, but all I knew is growing up. I'm like, well, we already have calculators and we have computers, and I understand learning the basis, like what happens when you do this or this associativity or division. Like seeing what happens. Like I always like taking X and squaring and doing different things because then the lines and the geometry would pop out, and that was really cool. But I'm like, isn't there like a computer program that could do this? And I'm sure some existed, but then we get into like the age of like Wolfram Alpha, where it's like pretty much anybody with an internet connection can do it, and that's really freaking. Basically, knowing that it can be done and not having to go through all the rigmarole, which is even literally, I think, why Professor Wolfram's saying one of the reasons he built Wolfram language. It's like he's like, I'd rather not do the math myself. Why wouldn't I use computers to do the math for me? And I do think kind of like this AI art and everything is an additional thing. And I think ultimately, I think what Dubin had said a week or so ago is, I think ideal situation is going to be human beings working with computers to help optimize things. Because at one point within early in the Wolfram Physics project, I remember folks were saying that, okay, well, if we're going to try to like map out the computational universe or something like that, it's like you could have like, what was it? It was a proof, Jonathan's proof checking or determining function there. Like it could just go through, but it would require curation. So I'm like, all right, humans, computers, symbiotically working together to help maximize what we get out. I'm like, that sounds pretty good to me. Hey, Zombie Box. Yes, it sounds like a Neil Breen movie. Oh God, if they ever made a movie of this, I don't know. I think it would be pretty. Yeah, well, it is physical creativity. It's just like
That's what I was saying. We got to get a movie of Duvid made so that Jared Leto can method act that shit because that needs to fucking happen now.
I seriously think Duvid
It's
could write a
so
really
awesome
good
that
rap.
you're laughing. You're laughing at the mere mention of it. The mere mention.
It would be a beautiful. Well, that's because Duvid is a character. Duvid is a character. It's like, do I agree with Duvid on everything? No, but he's a very smart individual, and I just the whole. It's like, well, I don't necessarily laugh, but the whole like when he's like, yes, I epitomize the merchant and everything, and when he gets to do his merchant thing in a very convenient way, I see that smile on his face. He's like, I am embodying whatever the platonic form of what a merchant is. I'm like, hey, power to you, brother. But
The irony that.
well,
Can you hear me?
Yes.
Okay, good. Just checking.
But
I just thought how ironic it would be for him to be the reason someone had to come to Platonism moment. I never believed before, but now. Did you want to show any more, or do you want me to show a couple?
Oh no, show a couple of your things. This was probably the best. The big thing that I wasn't expecting is, why is there like an energy sphere there? It just harkened back to the anime and stuff. So all right, we're good with that.
It's awesome.
Oh, what are we getting? Let's pull. Ooh. Oh no. That looks like someone going through the pod bay doors.
Look at the name of it.
Oh, what is it called?
Vector spaces
vector
are
spaces.
cool.
I'm not
And
just saying that. Oh God. A vector is something that has a magnitude. What have you done? Oh God, the memes. The memes. What is this?
It's pretty
Astro
good, eh?
Boy. Oh my God, Magna style.
Back in grade school, we had like themes to our classes, and in grade 3, it was Astro Boy, and I was like, "Damn, he's awesome!" So
I still
I think
need
it
to
worked out
watch
pretty
that
well.
movie. No, I like it. I like it. Ooh, that's pretty. Large
It's great,
pink
eh?
spheres floating in the air, in the ether, yes,
Yeah, this
yes.
one's not mine. I made
I
that one, yeah. I liked it, especially the top left one. Like, I just stare at that sometimes. I'm just like, it's so beautiful. I don't know
and
if you
ag-
ever get moved by art like
and
that, but
again,
yeah.
why is every represent? Why does it always seem like a lithium atom? We're always gonna have those 3 electrons plus the 1 new. Oh, I see. Okay.
This one worked out really good too, and I was able to get an MC Escher one that I thought was. It only took a couple tries to get one that I was like,
Oh God.
seemed to be able to parse that one quite a bit. So
So
sometimes the trick
birds,
is just
dolphins, or stairs. So describe it. Yeah.
I kind of love the way it's not even quite an Escher. It's like got more depth than an Escher.
Well, it seems to have a more of a center focal point there than a lot of the Escher things. Kind of just extend to the boundaries. But yeah.
Yeah, it has that. That wasn't even what I was thinking. I was thinking more just like the amount of shading it was able to do because Escher had a pretty limited medium. Like that's kind of what his genius was, is that he made those on a lithograph, I think it's called, which is like basically like a stencil.
Oh. Is
So
that like an Etch a Sketch?
it's probably more. There's probably more creative control than a pure Etch a Sketch, but you're talking about something that's like he probably would have had to carve out every last bit, and then it was a stamp. Escher's
Oh.
not
Yeah,
quite.
that's right.
But I'm obviously severely simplifying that, but something along those lines.
Yeah, no, you would have one of those representations like that, and then yeah, you'd have to just literally just either carve that into wood or something. Wow, we're so freaking blessed to have technology. But
I know. It's just like it's scary because every single job is going to disappear. Not every single one, but every job will be changed in some way, and a lot of jobs are going to be gone. So it's going to be like crazy.
yeah, well, you better get to
That's
building those
why
replicators so we can have a true post-scarcity society, so we can, I don't know, maybe start actually exploring the cosmos and actually give folks decent minimum standard of living. And then if you want to do crazy cool stuff exploring the cosmos, power to you. We can diversify our planetary habitation, so just in case something really bad happens, humanity can persist.
well, also we could learn to live in a way that doesn't destroy the planet.
I
Where
mean, that
we're
would
more
also
focused
be,
on intellectual stuff, like what we're doing right now. You know, we could be out shooting cans in the desert. Isn't that right?
I don't get me wrong. I'm not
I'm
gonna
not
say that
against shooting cans in the desert or anything. I'm
I'm not
just
gonna say I
saying.
haven't ever plinked cans or stuff, and there ain't nothing wrong with that. But
I'm just
give folks
saying,
the
like,
opportunity and make it. Don't scare people off. Don't be like, oh, here are all these 42-point words and stuff, and we're terrifying people. It's like, no, you got
no,
Wolfram Alpha. You can ask a question, and we got this art. If you have an idea in your head, kind of play around with it a little bit and see if you can come up with something. And maybe if it doesn't, if you basically, if we're all going to be entangled and all this stuff, it's like, all right, well, if everyone affects everybody, it's like, all right, well, you come up with a piece of art, and all of a sudden somebody's just perusing along, and all of a sudden they come across this, it's like something just clicks in their head, and it's like, all right, now I do. I'm like, well, if we have the internet and everything's time stamped and dated, I'm like, well, just give credit where credit's due. That's all. Now you inspire people rather than being like, oh my God, I'm never going to be able to do this. And if I put this idea out there, someone's going to steal my idea and take all the credit for it. It's like, if you put the idea out there and it's like, well, this idea came from here and you got this from this, it's just let
it's like,
people
why
know.
don't we just share? Let's share the ideas.
Yeah.
Let's share the ideas, and let's have a situation where we're sharing stuff. We're happy about what we're sharing, and we're also happy about what we're not sharing. I'm not saying I already have a plan for what that looks like. I don't think it looks like anything. It's just the mere fact of being comfortable with those two things and those things existing. It can happen, you know. Here, an idea I had along those lines: these tiny little succulent things that just grow and grow and grow. but you have to pick all the other stuff away, otherwise they'll get overrun with like grass and crap. That could be the currency.
Yeah,
No,
get
just
it.
kidding. I know plants as currency is a terrible idea, but yeah. Anyway, I just wanted to say that the solution is just going to be to focus less on materialism. I think we can keep a high level of tech as long as we realize we're just too much in the materialism is causing too much environmental despair.
I mean, personally, I totally agree with that. Well, apparently, I think it was the Dutch. I think they tried to do that with tulip bulbs at one point. At one point, like a tulip bulb, you could like one or two of them, you could buy like an entire home, and then people kept producing tulip bulbs, so the market completely crashed, and it didn't go really well for them. But yeah,
Absolutely not. No, we gotta focus on what's important rather than being at the whims of the market, which frankly, you can't just keep making silver cheaper forever as a way to, loosen up credit to make, stuff work. It just
yeah, we need to start having some gains that can, I don't know,
the
as
thing is
long as
like someone like Thad, it makes me feel really hopeful about the future because maybe other people can feel like him and that's enough.
the
Like, do you
man's
think that
the man's passion is unrivaled. That's
like I
one of
don't
the
know if
things that I
one
took
man's
away.
passion is enough, but I think something that makes a lot of men and women passionate, you know, I think that's important.
Well, that's the thing. Just having just being that okay, things that we or many people have been saying there are impossible actually might start being possible, and just that enthusiasm and just seeing what people can do with that, just I mean yourself included, just even just like your level of just I love this art and everything. I mean that is inspiring, Jen. No, it's like these are the folks that inspire me and stuff. And if we can get some more of that good juju out there, that's one reason I talk about this stuff, and I don't try to just beat people down. It's like I'll just say if I disagree, I disagree. And hey, my mind is totally open to be changed because I'm just a dude on the internet. Hey, to quote the Macho Man Randy Savage.
Did
we're
you
in
want to go
this
back to the
together.
thermodynamics thing at all? Because I don't really feel like I answered that.
We
If
can
there
do
was
that
something
real
in
quick.
particular in thermo. Because
Can we
the
set that for
problem that
another
we
day?
have with thermo is that it's like our current understanding of it is revolving around a really specific definition of closure, like a closed system, open system, the Carnot engine and stuff like that.
Hmm.
That definition is very limited.
Well, I mean,
So,
we came up with it like 150 some odd years ago or so. I mean, yeah, I mean, it's not like we have better ability to figure stuff out.
and I guess it was like disruptive tech at the time because the guy, I always harp on this, but Boltzmann got like harassed a lot and treated bad and killed himself. You know, partially just because people weren't agreeing with him. So I guess it's just sort of like taking a while to digest it. But now I'm basically saying, no, you got to relook the whole thing and stop trying to put a boundary on stuff and never put a boundary on stuff ever. And you can have models that are like a kind of a boundary, but even those, you got to make sure you're using the right boundaries or your calculations are not going to make any sense. And time and space aren't boundaries. So they're the result. And you want a theory that gives you stuff you care about, like time and space, not that you have to put stuff in that you already know exists. That's sort of like a little bit of a difference there. So, you know, I don't really honestly think this tech is going to be that disruptive because once people learn how to use it, they'll realize it's intuitive and that intuitions are things that you have in you. So it's not really new in any real sense. It's just a new application of your existing intuitive faculties. So yeah,
Yeah, well,
just back to what I said
it's a
originally
tool.
think of what I'm presenting as an equivalent of the Cartesian plane, except that physicality is integral with mathematics. So the Cartesian plane doesn't actually have any physical representation. It's just a concept that has, I don't want to say it doesn't have meaning, it just doesn't have a physical correspondence to it. Do you know what I mean by that?
Sounds kind of imaginary.
It's like in the sense that parallel lines, do you know why parallel lines don't exist?
Because there's some level of curvature.
In my system, the reason that they don't exist is because of entanglement or dependent arising.
Go on.
So, perpendicular is not entanglement. For two things to be perpendicular means that they're separate. And that is not possible. So the Cartesian plane is 3 degrees of perpendicularity. So that's 3 degrees of impossibility plus the ambient space. So you could argue it's 3 plus 1 degrees of impossibility. But not, I mean, the space in it arguably isn't a contradiction, but its own structure of perpendicularity is, I don't want to say a contradiction because my system also defines contradictions differently, unfortunately, but it's incompatible with my physical system. And so as you can see in the diagram I put in before, that there's no straight lines in that, or parallel lines, or perpendicular lines. And that's because the concept of two things being different is not really possible in my system. Do you see what that means by different? Like how X is different from Y? They're the same substance, quote unquote, but they're defined to be maximally different.
I believe Professor Wolfram refers to those as eames, or atoms of existence.
Sure, yeah, like I've called them basis vectors before because there is like something that's approximately perpendicular, because obviously it's like we have to have it, I mean, we have to have something like it, but yeah, a basis vector.
This also goes into something else where it's like, here's a question. Do we need a bigger collider or maybe some more interesting things? Because as far as I understand it, like we're smashing together like protons and particles like head on. I'm like, what if we did something like this? What if we try doing it perpendicular? Might we learn something new? Maybe we don't need something as large as the Large Hadron Collider to do that?
I don't think we need to do experiments. It's pretty obvious that we can just deduce it and then apply the technology immediately and calibrate it in the situation that we're using it.
Well, I mean, the technology will still be experimental and stuff. So, I mean, you're going to have experimentation in one form or another. And
it's always experimental because your only real constraint is 3 plus 1. Like the only real rule is that you can't have quantum state exclusion. And the excluded state is 3 plus 1. That's the only rule, is you can't have the excluded state. But hilariously, the 3 plus 1 is the complement of 3 plus 1 in a way. Because is there more information in the hyperbolic figure 8 or in the complement?
So I've been listening to some things before, and I do think I think you were probably right about the complement actually generating the action. Because at one point I'm like, onto these things, I'm like,
oh my god, fuck, I'm so glad you said that because I was starting to feel like nobody was ever going to understand it. But please
no. Well, to be fair, I went back and Thad had told me when I was to recommend what people should look at first, he's like, show them like the simplest universe or something like that. And when I was looking for citation for the hyperbolic vortex equation, I went back from 44 to source code 7. And then I realized, oh, Amazon recommended. Oh, look, a perfect universe. Let me go back. Oh, that was published even earlier. Huh. This is, and I'm not sure if you use what is it that Kindle Kindle books or have access to a Kindle reader at all. I'd like to lend you a copy of that because some of the stuff initially in that, some of it may be a wee bit outdated, and I think Thad said he may have moved on from some of the concepts. But all I know is some of the concepts that were laid out in there go into more of traditional, like it sounds more like signal processing and stuff. And I know that's more up your alley. So I'm happy to lend you a copy of that if you want to go through that. It's also a lot shorter. But
thanks. I mean,
it also has a lot more words than just like computation and stuff. I feel like one of the reasons he published 44 was literally so he could be like, just check it himself and everything. It's like, all right, here's my guidebook to quote unquote hacking the universe or whatever it is. So he could understand it, and he has more minimal words, whereas this one, it's written in a more elegant fashion, more of a narrative style way. It's also easier for me to read. But That's all I
And
got.
did you get anything out of it?
It's
Such as?
I'm gonna take the fifth on that one. But
It's
Jen,
hard to want to read a book. It's hard to want to read a book when the person who's recommending it can't say anything about it.
There's
That's
another reason for that. I try to keep certain conversations I have that are behind the scenes, and I respect people's privacy. But there are reasons.
no, that's fine. I totally understand.
Yeah, it's.
Don't worry
I
about it.
realize I'm being extremely obscure as somebody that likes to do things out in the open.
It's
But
fine. I don't read a
is
lot
earned.
of books. I don't read a lot of books. But if I'm going to recommend a book, I'll tell you why. Because I feel like reading a book is a bit of an imposition.
Okay, that's fair.
Personally, because it's like, as in terms of a medium, it's really hard. Reading is harder than watching TV
Oh yeah.
and talking.
Not everyone can read, but more folks can tend to.
Well, maybe
tend to listen.
reading's easier than talking. I don't know, but you have to want to read what you're reading, I guess, for it to be easier than talking.
Let me put it this
But
way: it's also a lot more elegant in its writings and everything.
but if you think it actually has stuff that would be useful for us now to like teach people to understand better, then that might be totally worth it. Like maybe just send me a screen grab if like there's a diagram.
I could give you like the actual like pages, and if you want, I'll send you some snippets basically with the page references, and if you feel like going any deeper, you can feel free to. So that's probably easier.
Woo!
Cool.
Yeah, so I see Kotov saying some comments in the chat. I'm not too sure. I don't use math in my system. I use logic. So you can use any math you want. Math is like the last step when you have to measure something. You can compute it any way you want.
Well, hey, these things happen, but I gotta run and do my other little video thing there. But thank you for
Good
popping
time
in, Jen.
talking.
No,
Good time
we need
talking,
to do
and
this
looking
again
forward to the
more.
next one.
Absolutely.
And
So
can't wait to continue the convo and hopefully get some interesting. Got my fingers crossed for animation AI coming soon. And I want to look like Tom Cruise in Minority Report before long. Was it Tom Cruise? Who was the one who was manipulating the thing to looking at the anyway? Whoever was manipulating the 3D computer to look in the future. That's what I want to be, but designing stuff out of pictures. Anyway, you'll see.
God, it's coming back now. But hey, that's all we got.
Woo!
Is it hyperbolic reality? We're gonna have to see. Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.